This is section 12.5, and it's called combinations. What's going on here is that we have these two things now, permutations and combinations. And permutations we talked about. This is when we have a group or a subset of how we can list things or how we can order things. And here order matters, okay? On combinations, the order doesn't matter. The way I like to think about this is for permutations, I gave you guys the ice cream cone, okay, where if you had 3 scoops, chocolate, vanilla, strawberry, this is not the same as, say, vanilla, chocolate, strawberry. Even though I'm using the same 3 flavors, they're in a different order, okay? The way I like to think about a combination is if you get a bowl of ice cream, okay? If you get a bowl of ice cream, you can throw in here vanilla, chocolate, strawberry, okay? And you could throw it in a different order, say chocolate, vanilla, strawberry. But you know what? It's still the same thing because it's still just ice cream sitting in a bowl. There is no order to the scoops. It's just a mess of ice cream, okay? So in combinations, order doesn't matter, and permutations, order does matter. It turns out we have formulas for these, and this is what they look like. The way we usually say this is we say the number. So let me move down to here, how it works. For this one, for permutations, you would say 9 perm 4. 9 perm 4. I believe I've heard it pert also. I think I've heard 9 pert 4. I think perm is the better the better choice. And then for combinations, the way we say this is 9 choose 4, okay? So you have a set of 9 things and we're going to choose 4 from them. How many ways can we make an ice cream bowl, okay? Over here it's you have 9 and you're going to pert 4 of them. How many ways can we arrange the 4 people or 4 flavors of ice cream in a certain order, okay? This is the formula for them. However, in the same place where the factorial button was hiding, you're going to find these formulas in the in your calculator too. And each calculator is a little different on how you put them in. Sometimes you put the number, so you'll type in 9, and then you'll go to the probability button, and you'll choose either P or C, and then you put in the second number. Sometimes you hit the button first and then you hit the 2 numbers. So you're just going to have to play with it and figure out what's going on, okay? And lastly, again, order matters for permutations and order doesn't matter. And you can think of an ice cream cone or an ice cream bowl. Let me do an example. Okay, here's a question that you can expect to see from combinations. We have a committee of 5 people is selected at random from a group of 10. There's 6 women in this group and 4 men in this group, okay? How many different committees can be chosen? This is the key word here to know that it's a combination, is how many different committees can be chosen. If it didn't say different and it just said how many committees can be chosen, then it would be a permutation, okay? Because it doesn't matter. It doesn't matter if we get the same grouping as long as it's in a different order. So, because order matters in permutations. But since it's different committees, we can claim this to be a combination, and all we have to do is type into our calculator 10 choose 5, because we're choosing 5 people for our committee out of 10 people. So 10 choose 5 is going to equal, and I need to go get the bigger graphing calculators. It's what I thought. You put in the number first, and then you hit the then you choose. And then you choose 5. So 10 choose 5 is what I've put in my calculator, and I get 252. Okay, so there's 252 different committees that can be chosen. Next question asks, what's the probability that Eileen and Ben are on the committee? For this, what we're going to... Okay, part B asks, what's the probability that Eileen and Ben are on the committee? Okay, this means we have to think how many Eileens are there. Okay, there's only one personal Eileen. So what we're going to do is how many Eileens are there? There's 1, and we're going to choose one of them. We're going to multiply this because we want Ben to be on there. So and Ben, okay, and Ben. So we'll multiply. This is going to be, there's 1 Ben, and we'll choose him. Okay. But then we also need to choose 3 more people out of how many people do we have left? We've used 2 people, so there's 8 people left, and we're going to choose. We're going to choose 3 more of them. Okay. However, this is a probability question, so we need to put it over the entire sample space. How many committees were there that could have been chosen in general? There was 252, so we can just throw this up like this over 252. Again, you're going to need to go to a calculator, and I'll do that real fast. Okay, this comes out to be 56 over 252, which is equal to 0.22222222222 forever and always. And percentage-wise, this is a 22.2% that Eileen and Ben will both be on this committee of 5 people. Okay, part C is going to ask, what is the probability that exactly 3 women and 2 men make it onto this committee? So what we're going to do is we're going to think, how many women do we have? There's 6. And how many do we want? We want to choose 3. So there's going to be 6, 3, choose 3, 6, choose 3. And so we're going to multiply. And we want to choose 2 men out of how many men? 4. So it's going to be 4, choose 2. This gives us our 5-person committee. We've chosen 3 and we've chosen 2. That meets our 5-person committee that we're trying to get. However, we're asked for the probability, so we're going to have to divide by the entire sample space, which was 252. Again, this is going to take some calculator work. For those of you that have the TI, I can show you guys on this video how it goes. So you go 6 math probability down to 3, which is the choose. Type that in, type 3, hit enter. That gives you 20. So this is 20 times. And then we're going to do 4 math probability choose 2. And this gives you, there's 6 chances. 6 times 2 is 120. Divided by 252. 120 divided by 252 is equal to 0.47619. And this can be thought of as 47.62%. Okay, so this means that there's a 47.62% chance that there will be 3 women and 2 men on this committee. Okay, this is how combination is going to be working. The first thing you have to decide is it a combination or a permutation? The next thing is usually find the entire sample space. Once you have the sample space, you have this for the rest of the problems because it's going to ask you for probability. Then it's thinking about what is the number that I have and how many am I choosing, okay? We'll be working on this on Monday. If you have any questions or comments, please let me know.